Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study problem number 3, which is based on convolution of signals using inverse Z transform. Basically, today we are going to study a different numerical. Now, in previous two numericals, we used to find out a Z transform of function, and then later on we use inverse Z transform. But now here the function is already present in Z transform, and we have to use inverse Z transform, and then we'll write it in original format. Now we'll see the question first. Problem number 3. Find the inverse Z transform of x of z, which is z upon z minus 1 whole square, using convolution theorem. Now here the question is not given in terms of x of n, it is in the form of z, or you can say the function is in Z transform. Now we have to obtain the time domain or discrete domain format of x of z, but using convolution theorem. Now I'll show you how to obtain the x of n. Now look at here, our function is in the form of z. Now what we are going to do, we are going to find out inverse Z transform. Basically, I can split this function in two parts. Let's say the first part is z upon z minus 1, and another part is 1 upon z minus 1. So if we multiply both these parts, then in denominator you will get z minus 1 the whole square, and in numerator you will get z into 1 is z. So let's say my first part, that is z upon z minus 1, is x1 of z, and the second part is x2 of z. Now basically x1 of z into x2 of z, according to convolution theorem, two functions can multiply with each other when it is in Z transform, only when the discrete samples, that is x1 of n and x2 of n of x1 of z and x2 of z, convolve with each other. So I can write, if we apply inverse Z transform on this, then I can say that this x of z can be represented by x of n, and x1 of z can be written as x1 of n, and this is nothing but my x2 of n. Now basically, what is my x1 of z? x1 of z is my z upon z minus 1. Let's say this is nothing but my equation number 1, and my x2 of z is 1 upon z minus 1. Basically, while applying inverse Z transform, we must have one z in the numerator of any function. So we'll multiply numerator z into z to the power minus 1. Now my x2 of z is 1 upon z minus 1. Basically, whenever we want to apply inverse Z transform, then it is necessary to have one z in the numerator of any function. So how to achieve or how to get one z in the numerator? What I will do, I'll multiply numerator by z to the power minus 1 and z to the power 1. So if the bases are same, then powers always get added. So 1 minus 1 becomes 0, and z to the power 0 is always 1, which means my substitution is correct. Now what I will do, this is my x2 of z. Now if we are going to find out the inverse Z transform of x2 of z, then what you will get, if we apply inverse Z transform on both the sets, then I can say that this x2 of z is nothing but my x2 of n, and z upon z minus 1 is simply u of n. But here this z upon z minus 1 is multiplied by z to the power minus n, which means if any function is multiplied by z to the power minus 1, which means here the function, the original function which is in discrete domain, is delayed by this minus 1 value. So I can say that this is nothing but the Z transform of u of n minus 1. Now my x1 of z was z upon z minus 1, and if we apply inverse Z transform on this, inverse Z transform of x1 of z is x1 of z can be represented by x1 of n, and z upon z minus 1 can be represented by u of n. Now I will use these two equations. Let's say this is my equation number 2 and this is my equation number 3. I'll use these two equations in the definition of a convolution of discrete signals. Now I'm going to use a definition of convolution. So here I have used a definition of convolution. When any two functions convolve with each other, let's say x1 and x2 will convolve with each other, according to property of convolution, I can write this equation. Now, so x1 of n can be convolved with x2 of n, or else you can say that x2 of n convolve with x1 of n. Now I will use the definition of convolution. So according to definition, we can write summation where k value varied from minus infinity to infinity x2 of k into x of n minus k. Basically my x2 of n is u of n minus 1. So if I replace this n by k, then what will happen? This n is also replaced by k. So I can replace this x2 of k by u of k minus n. Now what about this? My x1 of n is u of n. So if I replace this n, if I replace this to n by n minus k, then x1 of n minus k written as u of n minus k. Now I'll substitute both this value in equation number, let's say this is my equation number 4, this one is a 5 and this one is the 6. So I'll substitute 5 and 6 in my equation number 4. So after substituting my 5 and 6 value in equation number 4, I have got this equation. Now I can write this u of n minus k like u of minus k plus n. Now I'll draw the graph for both these equations. So u of k minus 1 is, first of all I'll draw u of k. So my u of k is starting from 0 and having amplitude 1, and it is having amplitude 1 till infinity, that is but if we add delay in this function, then u of k minus 1 means what? All the time instants will be shifted towards right hand side by 1. So this graph was actually started from 0, but if we add this delay, then this graph will start from 1, but of course it will terminate at infinity. So if we add the delay, our graph will start from 0 having amplitude 1 and it will continuous till infinity and the amplitude will remain same. Now I will draw the graph for u of minus k plus n. Now first of all I will draw u of k, then I'll advance this graph by n and then we'll take the mirror image of it. We have already plotted this u of k value. So if we advance this graph by n, then what will happen? Our graph will start from n, but from left hand side having amplitude 1. Now it will continue till infinity and it is also having amplitude 1, and this is the graph of u of k plus n. But if we find, or if I draw the mirror image of the same, so the mirror image of this equation is so how will you draw the mirror image? We'll multiply minus sign with each and every instant of time. So this graph will start from minus infinity and having amplitude 1, and it will continuous this n value, because here the graph is started from n and this n is on left hand side. So after taking a mirror image, this graph will terminate on right hand side at n, and at n also it is having amplitude 1. Now look at here. If I multiply both this graph, if I overlap u of minus k plus n on u of k minus 1, or else you can say that if we perform multiplication, then what will happen? Only you will get the answer for n is equals to 1 to n, because here on left hand side of u of k minus 1, the graph is having amplitude 0. So you will get the value only from n equals to 1. But look at here, u of minus k plus n. Here the graph is only available up to n, and n onwards it is having amplitude 0. So if we multiply these two graphs, then from n onwards till infinity it is having amplitude 1, but here we have amplitude 0. So after multiplying these two graphs, the next part of this graph, that is from n onwards, the graph will have the amplitude 0, which means I can say that you have the value of this graph but only from 1 to n. So I can replace this summation value from 1 to n, and now here we have a discrete samples having amplitude 1, but these values started from 1 and terminate up at n, or you can say this amplitude. Now here the summation value, the k value started from 1 to n, because after multiplying these two graphs, the answer will have a first sample value at 1 and the last sample value at n. That's why we are going to replace this k value from 1 to n. And now look at here, in between 1 to n, all the samples having amplitude 1, so I can write here the whole multiplication is replaced by 1 raised to k. Now what I can write, x of n is equal to summation value, the k value varies from 1 to n, and this whole product is replaced by 1 raised to k. Now we can use one formula, and the formula is summation n value varies from n1 to n2, and if we have a raised to n, then the answer is n2 minus n1 plus 1, and this formula is valid only if my a value is 1. Now look at here, my a value is 1 and here my n value is k. So I can treat this formula. So I can say that my n2 value is n and my n1 value is k. I'll substitute both this value in my formula. So why I can say that x of n is nothing but, so if I substitute both this value in my formula, then what I can say, my n2 value is n, so I'll write n first now, and my n1 value is 1, so I'll write over here, and then plus 1. So minus 1 plus 1 will get cancelled, my x of n will be nothing but only n, which is multiplied by 1, and this 1 is nothing but the amplitude of u of n, so I can say that this n is multiplied by specially into u of n. So if you go for z trans of n into u of n, you will get the same result which is mentioned in question, that is x of z is nothing but z upon z minus 1 the whole square. So this is nothing but the inverse z transform using convolution method. Now in this type of question, what we are going to do, we are going to split our x of z function into two parts, and then using convolution theorem we are going to split both this function, and then we will solve it using the formula of convolution, and then we can obtain this x of n value. Now we will solve a similar type of question in next coming videos. So for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.